Hello all, talking about right triangle trigonometry today. Just some general knowledge on regular triangles. Number one here, the sum of all the angles in a triangle equals 180 degrees. Number two, the shortest side of a triangle is always opposite the smallest angle. And conversely, the longest side of a triangle is opposite the largest angle. These are true for all triangles. Now, specifically for right triangles, the Pythagorean theorem comes into play. A squared plus b squared equals c squared is what everyone remembers. But one of the details of the Pythagorean theorem are that a and b don't necessarily represent specific sides. They represent the legs, right? The legs are the sides that make up a right angle. If you're looking at a right triangle, the first one here, this is a leg, and this is another leg. Right, if the triangle is flipped around, the leg is here and the leg is here. These are identified by, again, the sides of the triangle that form the right angle. And c squared in the Pythagorean theorem represents the hypotenuse to the second power. The hypotenuse is the side that is opposite the right angle. Building on that, the word opposite is going to come into play a lot, right? The word opposite over here, it's going to come into play a lot with right triangle trigonometry. Specifically, if we label an angle up top here as theta, that's the Greek letter theta, I call it an angle of focus, right? Because this is the angle that we're kind of looking at, and then our opposite side is going to be labeled accordingly, which is, if you take your finger and put it on theta, and then draw a line, an imaginary line or whatever, to the other side of the triangle, then you have located the opposite side. The hypotenuse is always going to be opposite the right angle. So if you do the same thing from the right angle, then you can find the hypotenuse by, again, putting your finger on top of it and just drawing, moving your finger to the other side of the triangle in that manner. And the adjacent side, you can think of as two different ways. If you identify opposite first, hypotenuse second, then the adjacent is just the third side that's left. Or you can identify the adjacent side as the side that forms the right angle, the side that forms your angle of focus, in addition to the hypotenuse, which will always be your angle of focus as long as it is one of these other angles on a right triangle, right? So your angle of focus can be in basically one of two different locations, right? It's going to be rare that your angle of focus is the same as your right angle, which means that your angle of focus can be up here, or it can be down here on a way this right triangle is drawn. The hypotenuse is always going to be, I just realized I spelled hypotenuse wrong over here, so let's fix that. Hypotenuse. The hypotenuse is always going to be opposite the right angle. The one that's going to change based on your angle of focus are the other two labels, opposite and adjacent. Opposite is always opposite the angle of focus. So if your angle of focus, again, is up here, then your opposite is down here. But if your angle of focus changes to this location, then your opposite is going to be in this location. And adjacent, again, is the second side, not the hypotenuse, that forms your angle of focus. So if your triangle is drawn differently, then your labels are going to be different. So I'm going to hesitate to refer to left side, right side, bottom, and top. I'm going to refer to them as opposite, adjacent, and hypotenuse, because that's going to be, those labels are going to be correct no matter what, right? Again, if we change our design over here, hypotenuse can end up on the bottom, Adjacent can end up on top, right? Hypotenuse can end up on the left side. Opposite can end up on top. So it really depends on how this triangle is drawn. And your angle of focus. Right, so let's get into SOHCAHTOA, which is a mnemonic device. SOHCAHTOA stands for the sine is equal to opposite over adjacent. Right, that's what SOA stands for. C stands for cosine. And cosine is followed by A and H, sorry. I'm sorry. I messed that up because sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. T stands for tangent. And since that's followed by O and A, that is going to be opposite and adjacent. So these are the letters in SOHCAHTOA, SOHCAHTOA, and these are their meanings. Sine, opposite, hypotenuse, and so on and so forth. So the sine function equals opposite over hypotenuse. Cosine function equals adjacent over hypotenuse. And the tangent function equals opposite over adjacent. Now those are the three main trig functions. There are three other trig functions, specifically the cosecant function, the secant function, and the cotangent function. The cosecant function can be thought of as the reciprocal of sine. So this would be hypotenuse over opposite. Secant function is the reciprocal of cosine. So that's hypotenuse over adjacent. And then you can take the tangent function and flip that around, take the reciprocal to be adjacent over opposite, right? And that would be the cotangent function. So there are 6 main trig functions here. Let's put them into practice. Given this triangle here, let's find the 6 trig functions of angle A and angle B. Now, if one of these was missing, we could use the Pythagorean theorem. 3 squared plus 4 squared is equal to 5x squared. 9 plus 16 is equal to x squared. 25 is equal to x squared. That means x is equal to plus or minus 5 if we solve this equation. Well, since this is a side of a right triangle, then the only value it can be is 5. We're not considering negatives. So let's look at angle A as our angle of focus. The hypotenuse is going to be here opposite the right angle. And if angle A is our focus, that means the opposite is across from it, and the adjacent is right next to it. So that means the sine of A, which is defined as opposite over hypotenuse, is equal to 4 over 5. The cosine of A, defined as adjacent over hypotenuse, is equal to 3 over 5. And then the tangent of A is going to equal opposite over adjacent, so 4 over 3. And if we flip these around, cosecant, which is abbreviated as CSC, is going to equal 5 over 4. Secant, SEC of A is going to equal 5 over 3. And then cotangent of A is going to equal 3 over 4. Now, if our angle of focus changes from A to B, take a look at what happens to these labels. All right, let's erase this so that we can start over. Hypotenuse is in the same location across from the right angle. But since our focus has now changed to angle B, the opposite label changes, and so does the adjacent. The values of 3 and 4 do not, because those are given to us as the sides of this triangle. AC must be 3, BC must be 4. But the labels of opposite and adjacent can change accordingly with our angle of focus, so that the sine of B is now going to equal 3 over 5, because 3 is the new opposite. Which makes the cosecant of B equal to 5 over 3. Cosine of B will change also to be adjacent over hypotenuse, so 4 over 5. And that will change the value of secant to be 5 over 4. Tangent of B is now opposite over adjacent again, but now 3 over 4. And then the cotangent of B is going to be 4 over 3. So these are all 6 trig functions of A and then of B. So in a right triangle, we're being told the cosine of theta is equal to 5 over 7. So that means we can draw a right triangle. Oops. We can label one of these angles as a right angle. That's fine. And we can draw our theta somewhere. Like there. And we don't have to label this A, B, and C because it doesn't say so. But remember that the cosine is defined as adjacent over hypotenuse. So if we put theta up here, this is now our angle of focus, and the adjacent side is next to it, and the hypotenuse side, again, is the side across from the right angle. Which means that we can label this adjacent side as 4, as 5, and we can label the hypotenuse as 7. 5 squared plus x squared is equal to 7 squared is going to help us find the measure of the opposite side, which is the third missing one. So 25 plus x squared is equal to 49. Subtract 25 from both sides. X squared is going to equal 24. Take the square root of both sides, and x is equal to plus or minus radical 24, which again, we will only consider the positive 2 radical 6, which is radical 24 fully simplified using the factors of radical 4 and radical 6. So if the cosine of theta is equal to 5 over 7, that means that the secant of theta is equal to 7 over 5. We did not need to know this triangle in order to figure that out, because again, the secant of theta is simply the cosine of theta flipped, reciprocal. The sine of theta now, we need to know as opposite 2 radical 6 over a hypotenuse, which is 7. And that makes the cosecant of theta equal to 2 radical 6, equal to 7 over 2 radical 6, right? We can multiply top and bottom by radical 6 in order to rationalize this denominator. 7 radical 6 over 2 times 6 is equal to 7 radical 6 over 12. And that's the cosecant of theta. Last 2 is the tangent of theta, which is equal to opposite over adjacent. That's going to be 2 radical 6 over 5. We can take this ratio and flip it to get 5 over 2 radical 6, which once again needs to be rationalized. So 5 radical 6 over 2 times 6 is equal to 5 radical 6 over 12. Now I do want to move this to a new page because I do want to mention, I don't want to delete it. There was one thing that I need to mention before we go. Let's copy this over to the next page. Oh, that was something else. Let's paste it here. All right, so this was our original triangle, which I will call triangle 1. Now let's say that you drew this triangle like so, but you decided to put theta down here. Does theta have to be up top? I'm always asked, how do you know theta is up top? And the answer is it doesn't matter, right? The hypotenuse is still the same location, but based on theta being down here, that means the opposite is over here, and that means the adjacent is over here. Now we saw on the previous example, opposite and adjacent switch. Right before, when our angle of focus was A, opposite and adjacent labels switched, but the measures did not. Now here, since this triangle is bound to the adjacent being 5 and the hypotenuse being 7, that means the 5 is going to switch accordingly with the adjacent. And again, that goes with the information that we're given, which is that the cosine of theta must equal 5 over 7. That's why 5 has to switch according with adjacent. So make sure that you are following those rules. Make sure that you are taking into account the information that you're given in order to determine which measures stay the same and which measures move according with opposite and adjacent. All right. Thank you very much, and I will see you